Oh yeah, second part of chapter 6. Let's do it. Okay, now we're going to get into actually starting to solve with radicals. Now here are the basic 3 steps. So at any time, I will go back to look at your notes. Did you do these 3 steps? Now, as we get into this, we will have things called extraneous solutions. And this is saying that mathematically we can get something to solve that's correct, but once I plug it back in, it doesn't make sense. We'll get to that first. So, my first step is to isolate the radical. So, pretend the radical is like a big X and try to get it all by itself. So, this right here, you want to try to get that out by itself. So, looking at this first problem, to get that by itself, I have to move over this positive 3. So since that's a positive 3, that means I have to subtract 3 from both sides. Now my radical is by itself. My 2x minus 3 would be equal to 5. Now you want to undo the radical. Now depending on what's here, it's going to look a little bit different. But undoing the radical is doing the opposite. If it is a square root, then you square both sides. If it's a cubic root, you would cube both sides. So in this case, this is a square root. I'm going to square both sides. Now, this undoes both of those. Okay, so now I'm just going to have the 2x minus 3 here. Now, 5 squared is equal to 25. Now, in this spot, this is like a pre-algebra question, and you guys are like, yay, I got this far. This is amazing. So if you were to solve this equation, you would get x is equal to 14. So B, I want you to pause the video and try to do B by yourself right now. And you should have gotten, first I add over my 5. Now I undo that root, so I square it. I add the 1, divide by 4, 13 halves. Now in every problem like this, I could plug in 13 halves to see if that will work. So if I go back, if I go a second and then x squared to get to my square root, 4 times 13 halves, I'm just going to do a division. Oops, I forgot my parentheses. So that's still times right there in your calculator. Minus 1. And if I have this, I'm going to take this first step. That's equal to 5. Or I could have done minus 5 at the end to see if it was like my original. So the first one was me adding over the 5, so that checks out. Or the second one is me plugging it into the original, and that still checks out. I want you to pause the video and to try to do C by yourself. So my first step is moving over this 3. So 7 take away 3 is 4. Undoing this root, so you're going to square both sides. 4 squared is 16. This right here, I subtract this 3. Don't forget this subtraction needs to go with that 2. So that subtraction stays with that 2. Now I divide, because the opposite of multiplying is divide by negative 2. Again, you can still plug it in. So for this one, a lot of times people get confused. If you go back up here, again, it says to pretend like there's a big X there. So this is the same type of problem as if I had 2 times, I'm going to replace it with an 8. And then minus 12 is equal to 0. My first step to solving that is to move this over. That's still my first step for solving this radical. So I add my 12 over first. Now, you never can, never ever have you ever, should you ever distribute this in. This is multiplying just like how you would move over this 2 times. You're going to move over that by dividing both sides by 2. Now your radical is by itself. So I want you to pause the video and finish off this problem. So you should have squared both sides, got 36, added over, opposite subtraction is adding over that 1, and then divide by 4. Wham, bam, thank you, ma'am. Now we get into something a little bit more different. So when I'm looking at this here, remember every fraction exponent can be written as a radical. So if I had like x to the 1/3, that's the same thing as the cubic root of x. If there was a 2 up here, we would have that 2 right here. So I will be showing you this in class. However, I want you to get used to rewriting this. Your first step for solving these is to still try to get this by itself right here. I'm actually going to do 2 things at once. I'm going to divide both sides by 3 here. And I'm also going to rewrite this part right here. So this x plus 1, I'm going to keep that as squared, just like how that has still that square there. Except this little 3, I'm going to rewrite it like we know how to write that as a root. So I'm going to rewrite that as a cubic root. And this would be equal to 12 divided by 3 is 4. Now when I continue solving this problem, to get rid of something, a cubic root of something, you have to undo that. So I'm going to cube both sides of the equation. So now I'm going to have x plus 1 squared is equal to 64. This is now where you have to be a little bit more careful. We've talked about this before, but to undo something squared, you have to take the square root of that. Now, when you take the square root of this side still becomes the x plus 1 because that's everything that's underneath that root in the squared. This is equal to the square root of 64 is 8. However, when you have an unknown number, an unknown whatever this is, squared, there's actually 2 answers there. This could be this right here, x plus 1 could be either positive 8 or negative 8. So we actually have 2 answers. We have to solve x plus 1 equals 8, and we have to solve x plus 1 equals negative 8. So if I solve here to subtract the 1, x would be equal to 7. Here, if I subtract the 1, x is equal to negative 9. And I'm going to show you in class how you can check this work so that you don't have to type this in more than once. So here, there's a couple more steps in play here. I first need to get this right here by itself. I want you to pause the video and try to get just that by itself first. So you have to subtract the 1, divide by 3. Now this is a 5th root. So you have to do the 5th power on both sides of the equation. Now 8 to the 5th power is going to be pretty large. So I'm going to have x plus 1 cubed is equal to 32,768. Now here's the kicker, guys. Over here, this was an even number. Remember, when something's squared to the 4th, that's always going to give you a positive number. Whenever you have an odd, it could be positive or it can be negative. It can't be both. So now when I do my cubic root on both sides of the equation, I'm only going to have one answer here. So when I have this x plus 1, this is only going to be equal to, and if you can't remember how to get your cubic root, you can either do raise the 1/3 power, so I already have that number in there, or you could also go to math, cubic roots down to 4, and put in 3,000 or 32,768. Either way, you should get 32. Oh, I'm not done because that x is not by itself, so I have to subtract the 1, so x is equal to 31. I want you to pause the video and try to do this one next. Again, first rewrite that root. So actually, I'll help you rewrite the root first. So this would be a cubic root of 4x plus 5. You don't have to write that one, but you sure can if you want to. Now I want you to pause the video and try to do that one by yourself. So you should have cubed both sides. And again, when you're doing this, you only have one answer because there's no exponent up here. So subtract the 5, divide by 4, you should get 11 halves. I want you to try to do this one by yourself. Pause the video, try to do this by yourself. And you should have gotten the 4th on top. Now this is where sometimes people get confused. They see that this right here is an even number, so they think, oh, I should have 2 answers here. This is not the same as over here. Over here, it's because this was even on the top right there. When I was solving, my unknown had an even exponent. When I'm solving, we can have even exponents when I'm solving. So notice how that's even in a different color of when I put this positive negative. So then you do 16 raised to the 4th power, you get 65,536, and then you subtract 1, answer is 65,535. And we're going to stop there for today because we're going to do E and F in class. So have a great and a grand and a wonderful day.